Hello, fellow students. Today, we will be talking about surds, indices, exponentials, and logarithms. The things covered in this video are the basic algebraic stuffs and the rules you need to remember, or at least know about these numbers. These things are first introduced to you in 11, but it will be very important in year 12 because they are assumed knowledge. And so it's very important for you to be very familiar with them now. First thing, let's just have some definitions. It's easy stuff. So a surd is a number on the root. So example is square root of 2 is a surd, and the square root of 3 or 2 is also a surd. And other than square root, you can also have cube root of 4 is also a surd. So most surds are irrational numbers. We prefer to keep them in surd form to preserve accuracy. So for example, you can actually prove that you cannot write square root of 2 as a fraction. If you want to write it in the decimal form, you can only write finite number of digits. If you only write 3 digits after the decimal point, you lose all the digits after it. So mathematicians prefer to write square root of 2 in this surd form, so we can have 100% accuracy. And although most surds are irrational numbers, you can have rational surds. So for example, this cube root of 4 is irrational, but you have the square root of 4, that's 2, which is the rational number. And by the way, the definition of a square root is always giving you a positive number. So, for example, the square root of 4 will give you a positive 2, no negative 2. That's just a definition. And next one, index, or sometimes called exponent, is a small number written on top of right of another number, indicating how many times a number should be multiplied. So for example, if you got an easy case where you have integer index, it's very easy to understand. 2 squared is basically 2 times 2. And 4 to the power of 4 means 4 fours need to be times together. But the things get a little bit trickier if you got other things on the index. So for example, if you got a fraction on the index, so for example, a 1/3 power, that basically means take the cube root. So basically, if you got the power to be in the form 1 over n, that basically means take the nth root of the number. So if it's 1 over 3 is the third root, if 1 over 5 is the fifth root, and next is the negative index. A negative index just basically means take the reciprocal. You put 1 over that number. So 10 to the power of negative 1 is 1 over 10. And 10 to the power of negative 2 is 1 over 10 squared. You can sort of think this negative sign here as the fraction sign here, fraction bar. And the rest of the numbers are just the power of the denominator. And 10 to the power of 1 is just 10. Now let's get on to the index laws. This is basically where the steps you need to memorize, or at least put in your cheat sheet, because they definitely will be tested somewhere implicitly. The first one is if you got two numbers which are the same base, this lower number here x, and raised to the different power times together, then index laws tells you that you can keep the base the same but add the two exponents. So for example, if you got 2 to the third power times 2 to the fifth power, this will be equal to 2 to the 3 plus 5 power. And next one is pretty similar. It's just division instead of multiplication. And as you know, division is the inverse operation of multiplication. To the other side is also the inverse of addition, which is subtraction. And the next one is tells you how you can merge two index together. If you got x to the power of a, then to the power of b, this means you can just multiply a and b together first, then calculate x to the power of the product. And then also you can switch the order around. It doesn't matter. You can take x to the bth power first, then to the 8th power. But you need to be aware of that this is not the same as x to the power of a to the power of b, which these things are stacked together higher and higher. Notice that I didn't have a bracket around x to the power of a here, but I have a bracket around here. The reason for that is because if you have bracket around, then it means that index law, then it means that you can multiply this 2 and 3 together to give you 2 to the power of 6, which is 64. But if you have this 2 to the power of 2 to the power of 3, then this means you need to calculate the top number first. You need to calculate 2 to the power of 3 first, which is 8. And then you take 2 to the power of 8, which is 256. And the next one is about how you can cope with fractional powers. If you have x to the power of a or b, then you can basically do it in two ways. You can first raise x to the power of a, then take the bth root, or you can take the bth root of x first, then put it in the power of a. And next thing is a trivial fact. It tells you that any number other than 0 to the 0th power is equal to 1. Next one is what I mentioned previously. If you have got a negative power, it just means 1 over the positive power. So make sure you are familiar with these laws, because the question may not explicitly say which law to use. They wouldn't tell you, but you need to know which law to apply in different situations. And to familiarize with yourself with math theorems and laws, the best way to do it is doing a lot of practice questions. So now let's have some go at these two practice questions. First one is factorize 9 to the power of x minus 4. So because the question tells us to factorize, we know we need to write them in some sort of products. The first thing we'll notice that 3 squared gives us 9 and 2 squared gives us 4. So these two things are basically the same. After you see the power of 2, the squared, or in these numbers, you know the difference between squares is going to come somewhere. So by index law, it says the order of the product of index does not matter. So we can basically switch these 2 and x around. And now we have the form to apply our difference between squares formula. So the formula is basically a squared minus b squared equals a plus b times a minus b. So in our case, a is 3 to the power of x and b is just 2. So apply that formula, we have a plus b times a minus b. And then you are done with this question. The next one is simplify 6 to the power of m plus 2 to the power of m divided by 2 to the power of m. So upon seeing this question, your initial guess should be you can somehow get rid of this denominator. Because you have this 2 to the m here, you can easily cancel this 2, but there's only this 6 to the power of m for there to stop you. So basically we need to do something to the 6 to the power of m to simplify this expression. So we'll notice 6 is same as 2 times 3, so we can write 6 to the power of m as 2 times 3 to the power of m. Then using index laws, we can separate this product, which gives you 2 to the power of m times 3 to the power of m, and the rest is unchanged. And now we can take out a common factor of 2 to the power of m. So this 2 to the power of m takes out, leaves the 3 to the power of m. And this one is 1 times 2 to the power of m. So if you take out the 2 to the power of m, it leaves you at 1. And then we can cancel out this 2 to the power of m, because 2 to the power of m power, it will never be 0. So we can safely divide 2 to the power of m on top and bottom. This will leave us to be 3 to the power of m plus 1. For y this never equals 0, you can think it for yourself, or you can do the graphical method.